Hi students, in this video I'll be going through two questions on maps and scales and one question on the converse of Pythagoras theorem. Right, so let's take a look at the first question. So for the first question, it says that a map has a scale of 1 cm to 400 meters. Express the scale of the map in the form of 1:n, where n is an integer. Okay, so over here we have a map. Okay, so what it tells us is that 1 cm on the map represents 400 meters on the actual ground. Okay, so let's write this down. Right, so the map scale is equals to 1 cm. So the left side always represents the map and the right side represents the actual ground. Okay, so 1 cm represents 400 meters. Okay, to convert it into the form of 1:n, we need both sides of the scale, so the map and the actual ground, to have the same units. Okay, so what we are going to do over here is we always convert this one, convert to cm, all right? Convert to cm. Okay, so that it can have the same units as the map, all right? Which is 1 cm on the left side, right? Okay, so now what we need to do is we need to convert 400 meters to cm. So if you recall, to convert meters to cm, we will multiply by 100. Okay, so that's what we are going to do. Okay, so once you multiply by 100, you have cm. Okay, so now let's calculate this. So 400 times 100 will give us 40,000. All right, so 40,000 cm. Okay, once the unit is the same on both sides, then we can remove the units and then we will have our answer 1:n. Right, so it will be 1:40,000. Right, so this will be the answer. So in this case, n would be 40,000. Right, n equals to 40,000. Okay, but in your answer space, okay, you will write this entire thing inside, all right? 1:40,000, all right? Okay, so let's take a look at part B now. Okay, so for part B, if a park has an area of 10 cm square on the map, calculate its actual areas in square kilometers. Okay, so now they want square kilometers. Okay, so if you recall, to do this question, we will need to first calculate the area scale. Right, so to calculate the area scale, okay, we need to take note of one thing. They want the actual area in square kilometers. Okay, so let's bring back the map scale. Okay, so if you recall the map scale, okay, we're going to start with this one, the initial one is 1 cm represents 400 meters. Okay, but now the question is talking about kilometers. Kilometers means km. Okay, so what you want to do is you want to convert this right side, the actual ground, into kilometers. So convert to kilometers. Okay, so if you recall, to convert meter to kilometer, you will divide by 1,000. Right, so let's do that. So let's divide by 1,000. Okay, so once you divide by 1,000, you have your kilometers. Okay, so now 1 cm represents 0.4 kilometers. Okay, once you have converted this to kilometers, then you are ready to find the area scale. Okay, so you are ready to find the area scale. Okay, so recall, why do we convert into kilometers? Because they want square kilometers. Right, so to get the area scale is actually very easy. All you need to do is to square both sides. Okay, square the map and square the actual ground. Okay, so square both sides. So you get 1 cm is to, okay, so 0.4 square, you should get 0.16, right? kilometers square. All right, 0.16. Okay, so what this means is that 1 cm square, an area of 1 cm square that you can see on the map, on the actual ground, it represents an actual area of 0.16 kilometers square. All right. Okay, so now they say that the park has an area of 10 cm square. So what would be the area, okay, in kilometers square on actual ground? So to go from 1 to 10, we will times that. So whatever you do on the left side, you just do the same thing on the right side. Okay, so this will be 1.6 kilometers square. Okay, so this is the answer that you write in the answer space. 1.6 kilometers square will be the actual area of the park on the ground, right? Right, so let's move on to the second question. Okay, so what you can do is that you can actually pause the video and try the question on own first before you continue watching the video to see my solution. Okay, so in this second question is slightly different. Now they give us the map scale. Okay, then they say that in pi on the map, the path has a length of 5 cm. Find the actual length of the path in kilometers. So once again, you see kilometers. Okay, so now they actually give us in the form of 1 is to n. Okay, so if you recall, 1 is to, in order to get 1 is to n, we need to change both sides to cm. Okay, so we need to change both sides to cm. Okay, so now since they give us in the form of 1 is to n, so when we go backwards, both are in cm, both sides are in cm, all right? Okay, so now we can write out the map scale. It will be 1 cm is to 50,000 cm. Okay, so now the question wants kilometer again. Okay, so what we want to do is we want to convert this one to kilometers. Okay, convert to kilometer. Okay, convert to kilometer. Okay, so if you don't know what to divide to get to kilometers straight away, what you can do is you convert to meter first. Okay, so to convert to meter, we will divide by 100. Okay, because 1 meter is 100 cm. So you will actually get 500 meters. Okay, then from meter to km, you divide by 1000, right? Because 1 km is 1000 meter. So you actually get this for your map scale. So 1 cm on the map represents 0.5 km on the actual ground. Okay, so now they say that there's a path that is 5 cm, right? So if this is 5 cm, then what is the length on the actual ground? So you see, to get from 1 to 5, you times 5. To get from 0. So we'll do the same thing on the right side. Okay, so 5 times 0.5, you get 2.5. Okay, so this is the answer they write in the answer space. 2.5 kilometers. All right. Okay, part B, the actual area of a rectangular park is 9 km square. Actually wants to draw the rectangular park on the map. Find one set of possible dimensions of a rectangle that can be drawn. Okay, so now they say that on the actual ground, there's this park that is 9 km square. Okay, but what we want to do now is they want us to know if we were to draw this park on the map, right? Okay, what will be one set of possible dimensions? So on the map, it's going to look like a rectangle. So what is one set of possible dimensions for the length and the width, right? So in order to do that, we need to know what is this area first, area on the map. Okay, so now what we need to do is we need to find the area scale. Okay, but let's bring back the map scale. Okay, so remember, they, they give us the actual area in km square. So what we want to do is we want to use this set of map scale. The one whereby the right side is in km already. Okay, km, all right? So the map scale is 1 cm is to 0.5 km. Okay, so now in order to get the area scale, what we want to do is we want to square both sides. Okay, so square 1, you get 1 cm squared. square 0.5, you get 0.25 km squared. Right? Let me write this neatly. Okay, km squared. Okay, so now the actual area is 9 km squared. Okay, so what would be the area on the map? Okay, so what we need to know this one, what is the multiple for the factor where you multiply by 0.25 to get 9, right? So the easy way to know this number is to take 9 divided by 0.25. Okay, so 9 divided by 2.5, you should get 36, all right? 36. So we know that this is times 36. Okay, so if you times 36 on the right side, then you times 36 on the left side. So this one will be 36. So now this area is 36 cm squared. Okay, so one possible set of dimension, you just need to think of two numbers. You multiply together, you can get 36. So one possibility could be maybe 3 and 12. 3 cm and 12 cm. So this question has multiple answers. Okay, or it could also be 4 times 9. Okay, 4 cm times 9 cm. Okay, so you just write down any one possible pair. Okay, so you just write one possible set of dimensions is 3 cm by 12 cm. Okay, or you can write 4 by 9 cm also can. Okay, of course, you want to write 2 by 18 also can. Yeah, so there's many possible variations of answers for a question like this. All right. Okay, so now let's take a look at a question regarding the converse of Pythagoras theorem. So the converse of Pythagoras theorem is basically using the Pythagoras theorem in reverse. Okay, so this one we just need to take note of the way to present your answer. Okay, so in order to know whether this is a right angle triangle or not. So the right angle obviously somewhere here will be over here lah. Okay, if it's a right angle. Okay, so what we want to do is we want to add up the square of the two shorter side, and then we get a number, and then we want to compare to the square of the longer side, hypotenuse, and then we see whether those two numbers are the same or not. All right, so for this kind of question, it's very important to write your working in two separate lines. So the first line, okay, we're going to find the sum of the square of AB square and BC square. Okay, we're going to find this. All right. Okay, so we're going to add together. Okay, so that will give you 1892.25. All right. Okay, then in a separate line, okay, this one must be in a separate line, okay? We're going to find AC square, right, which is 43.5 square. Okay, so we'll get 1892.25. So now these two are the same. Okay, so if they are the same, then we can conclude that this triangle is a right angle, and therefore angle ABC is 90 degrees. So we write the conclusion: since AB square plus BC square equals to AC square, triangle ABC is a right angle triangle. Hence, angle ABC is 90 degrees. Okay, so how do we know this? Because we have used the Pythagoras theorem in reverse. Okay, so we write converse of Pythagoras' theorem, right? Okay, so you must present your working in this way. Two separate lines, two different numbers. If these two numbers are not the same, then you conclude that it's not a right angle triangle. Okay, so remember, two separate lines. Okay, so you are not supposed to do this. So this is the wrong working. You're not supposed to write it like this. Okay, then after that, go and put in the thing. Okay, then put in the numbers. Okay, then after that, write like that. Okay, the reason is because, okay, for this question is the same. But what if it's not the same? Then if it's not the same, then at the first line you already write equal. And that's a incorrect way to present it. All right, so always write two separate lines, calculate two separate numbers, and then compare the two numbers. All right. Okay, so this will be the end of this video. Okay, so I hope that is helpful for you.